Hi there, folks. This is the Practice Chapter 7 test, and as always, I am the amazing Mr. Jansen. So here we go. If I take a look at this first one, I could solve each of these using logarithms. I can always do that to solve an exponential equation. But for these, there's actually an easier way. When I look at the 4 and the 8, I should recognize that they have a common base of 2. In other words, the 4 can be rewritten as a 2 squared. So instead of 4 to the x plus 1, I have 2 squared raised to the x plus 1. The 1/8 can be written as 2 to the negative third power. And again, just look at the denominator. 2 to the third power equals 8. So 2 to the negative third equals 1 over 8. That's how negative exponents work. And now when I look at this, here I have something being raised to a power, so I multiply the exponents. And really what happens here, if I rewrite this way, I'll show this intermediate step. But if I have the same base on each side, I can just set the exponents equal to one another. And then I can solve from here by subtracting the 2. And then dividing by the 2. Right? So again, when possible, I can rewrite this so that I have the same base on each side. Let me write it over here. And then just set the exponents equal to one another. That's the most basic and the easiest method for solving an exponential equation. I can do the same thing in number 2. Here they have a common base of 3. 27 is 3 to the third power. 9 is 3 to the second power. Again, when I raise something to the power, I multiply the exponents. I'm going to be distributing here. And I can see that I have the same base, so I'm just going to go right to setting the exponents equal to one another. That's going to be a 6x plus 24 equals a 4x minus 8. And now I can solve this for x. I subtract the 4x from each side. So I get a 2x plus 24 equals a negative 8. I subtract the 24 from each side. So I find out that 2x equals a negative 32. And then I divide by the 2. Okay, so again, when possible, we want to rewrite this so that it has the same base on each side, which allows me to just set the exponents equal to one another. Okay? If I look at the next one, I want to rewrite each of these as one logarithm. So the first one, if I want to condense this into one logarithm, I'm going to kind of follow order of operations here. I'm going to take care of this multiplication first. That multiplication I can bring up as an exponent. That's part of my properties of logarithms. So it becomes a log base 2 of y to the third. Everything else I'm just going to rewrite here. And now between the addition and subtraction, I just work left to right. So I'm going to take care of this addition that's right here. And I can combine that into one logarithm of the two things being multiplied. So it becomes an xy to the third. And now this last piece, I have 2 logarithms being subtracted, which means I can rewrite it as one logarithm of the two things being divided. So it becomes the xy cubed over 5. Okay, so I rewrite it as one logarithm of the two things being divided. Let me clear some space for that guy. And that's it. Okay. In number 4, I'm doing the same thing. This time I have log base 10, or the common log. So I'm just going to rewrite it as a common log as I work through this. Again, this guy can come up here as an exponent. So that becomes log base 10, or common log of 5 to the second, which is 25. Minus, over here inside the parentheses, I can combine these using multiplication, so it becomes log of xy. And now I'm subtracting these two things, which I can rewrite as one logarithm of the two things being divided. So that's 25 over the xy. And that's it. Okay, I'm condensing it to one logarithm. In the next two, I'm doing the very opposite of this. I'm going in reverse. So this first one, I'm going to split this into 2 logarithms. And the division I can split into 2 logarithms being subtracted, which becomes the natural log of 3x minus the natural log of y squared. And that's an ugly looking y. Let me try that again. And now from here, this first piece, I've got multiplication in here. I can split that into 2 logarithms being added. So it's the natural log of 3 plus the natural log of x. Minus, over here, I can bring the exponent out front. That's part of my expanding process. So that's 2 natural log of y. That's it. It's completely expanded. Number 6, I really have 2 options here. I could start by bringing this 3 out front. Now, if I bring the 3 out front, that's going to be a 3, and then the log base 2 of x to the 5th, y to the 2nd. And now I have multiplication inside that logarithm, which I can split into two logarithms being added. And now within each of those logarithms, I can bring an exponent out front. So here I can bring the 5 out front. And here I can bring the 2 out front. And I guess technically I could leave it this way, or I can distribute that 3 in, which is going to give me a 15 log base 2 of x plus a 6 log base 2 of y. Which brings me to the other method that I can take when I approach this problem, is I could use my rules of exponents here. Right here, if I raise this whole thing to the 3rd power, it's going to end up giving me log base 2 of x to the 15th, y to the 6th, okay? Because when I raise it to a power and multiply the exponents, now I could split this up in terms of addition. X to the 15th plus log base 2, y to the 6th. And then I can bring the exponent out front and get the log base 2 of x plus the 6 log base 2 of y. Okay? And when we look at the final answer, you'll notice that I get the same thing either way. Okay? In the next few, I'm just evaluating each of these. And with something like this, log base 7 and 98, I want to use my change of base formula. Remember, when I use my change of base formula, I'm essentially going to divide two logarithms. The 98 goes in the logarithm up top, and the 7 goes in the logarithm underneath. And I just always use the natural log. So I do the natural log of 98 divided by the natural log of 7. And the key there is it has to be the same logarithm on the numerator and denominator. When you plug this into the calculator, you need to contain logarithms using parentheses. So you're going to have parentheses around each of those. In fact, I'll show you if I pull my calculator up here. But if I take my calculator, I do the natural log, and then 98, and I have to close that parenthesis, then divided by the natural log of 7, and then I just hit enter. Okay, so it tells me that the approximate value here is going to be a 2.356. Okay? The next one, I can do the same thing here. This one I could actually plug into the calculator and just do natural log of 125 divided by the natural log of 5. And this is going to give me a 3. And the reason I know it's going to give you a 3, I just did it using my change of base formula. But the reason I know that is because this one can actually be done by hand. Keep in mind that if I have something like log base 5 of 125, I know that 125 is 5 to the 3rd power. And I know that log base 5 and the 5 are going to cancel each other out and just leave me with the exponent. So I can either do this by hand pretty quickly if I recognize it, or I can still use my change of base formula on the calculator. All right? For the third one that's here, don't get tricked into trying to do too much by hand. The 6 and the 3 are not going to reduce in this scenario, and that's why I put this problem up here. This one I have to use my change of base formula. And even as I write this as natural logarithms, I can't divide that 6 and that 3. It doesn't work that way. I have to punch this in the way it is, the natural log of 6 divided by the natural log of 3. Okay? And that's going to give me a 1.631. We'll go to 3 decimal places on these. Okay? And that's it. That's all there is to it. If I look at the next one, I want to solve this, but I have to combine the logarithms first, and then I'm going to undo those using this property that I've seen a couple times. B raised to the log base b of x is going to equal the x. Remember, if I have b raised to a logarithm, those bases are going to cancel out as long as they're the same. Okay. So what I need to do is rewrite this as one logarithm first. Log base 3 of x plus 6 plus log base 3 of x, I can combine into one logarithm of the two things being multiplied. And so if I multiply those two things, it gives me an x squared plus 6x. And that's just my distributive property, equals the 3. And now in order to undo log base 3, I have to do 3 raised to the power of each side. So I'm going to do 3 raised to this power equals 3 raised to this power. And again, this becomes my exponent. So each side of the equation becomes the exponent. The log base 3 and the 3 cancel. So it leaves me with an x squared plus 6x. Over here, I have 3 to the 3rd power, which is 27. And now I can solve this by factoring. I'm going to subtract the 27 from each side. So I end up with an x squared plus 6x minus 27 equals 0. and I'm going to factor this thing. This is going to factor into an x plus 9 and an x minus 3. And then I set each factor equal to 0. And then I solve each. This one I'm going to subtract the 9. Over here I'm going to add the 3. So I get two answers. I get x equals a negative 9 and I get x equals a positive 3. But remember, I can only plug positive values into the logarithm. So when I plug that negative 9 in, it would give me a negative 3 over here, which I can't do the logarithm of negative 3. It would give me a negative 9 over here. I can't do that negative logarithm. I also can't plug 0 in there, which is important as well. So this means that this one is an extraneous solution. I can try to plug it in, but it's not going to work. So my only answer is the x equals 3. In number 11, I'm going to approach this the same way. I want to combine these into one logarithm. And I can combine these using division. This is going to be log base 4 of x over 5. Again, I combine it in one logarithm, the two things being divided equals the 2. To undo log base 4, I do 4 raised to the power of each side. Over here, the log base 4 and the 4 cancel. So it leaves me with an x over 5. Over here, I have 4 to the second power, which is 16. And now to undo dividing by the 5, I multiply each side by 5. And I find out that x equals 80. All right, and I can plug this back in and check it, and I'll find out that it's going to work. Okay. Number 12, there's two ways to approach this. So I'll show it twice here. The first way, again, I'm going to combine these into one logarithm first. So if I combine these into one logarithm, it's going to be log base 5 of x squared minus 4 over the x minus 2 equals the log base 5 of 8. And then I'm going to do 5 raised to the power of each side to undo these logarithms. They're going to cancel on each side, so I'm going to be left with this. The x squared minus 4 over x minus 2 equals 8, which is like an 8 over 1. And I treat it as an 8 over 1 because I'm going to solve this by cross-multiplying. If I cross-multiply here, that's going to give me an 8x minus 16 equals an x squared minus 4. And then I can solve this by factoring. I'm going to get everything on the same side. So I'm going to subtract the 8x, and I'm going to add the 16 to bring everything over to this other side. And when I do that, on one side I'm left with the x squared minus 8x and a plus 12. And the other side I'm left with a 0. And then I can solve this by factoring. Let me bring that up here. That's going to factor into an x minus 6 and an x minus 2. And then I can set each factor equal to 0. And then solve each. Here I add the 6 to each side. Here I add the 2 to each side. So I get two answers that seem to be valid, but one of them is actually not. As I start looking at these, if I plug each of these in, the 6 is going to be fine, but the 2 doesn't work. And the reason for that is if I plug the 2 in here, it gives me log base 5 of 0, which is undefined. I can't plug that into my calculator. Here I would get log base 5 of 0, which again is undefined. I can't plug that into my calculator, so I can't use that answer because I can't plug zeros into the logarithm. I can only plug positives in. Can't have negatives, can't have 0. So the only solution here is the x equals 6. And I said there was another way to approach this one. And if I were to section this off a little bit, if I pick up at this step right here, so I'm going to pick up with that step right here, so I'm going to write that off to the side. If I had the x squared minus 4x over the x minus 2 equals 8, this is where I can differ my approach a little bit. Keep in mind that x squared minus 4 is actually x plus 2x minus 2 if I factor it. So if I bring that up here, that's x plus 2, x minus 2, all over the x minus 2. And you can kind of see what's going to happen. Those x minus 2's are actually going to cancel out. So I'm just going to be left with an x plus 2 equals 8. And so it kind of takes care of that extraneous solution for me. I subtract that 2 from each side, and I find out that x equals 6 is my only solution. Okay? So those are the two ways that you can approach that problem.